Welcome to this video, and in this video we're going to learn how to use Bayes' theorem. Okay, so in the previous video we learned about Bayes' theorem in depth. Okay, so we talked about some problems using Bayes' theorem. Okay, and in this video I'm going to teach you how to use Bayes' theorem, and also how to understand or how to know when the Bayes' theorem is applicable or when you should use the Bayes' theorem. Okay, so not only the formula to know the Bayes' theorem is important, okay, but also how to use the formula, and also in which situations we have to use the Bayes' theorem is also important, okay, to know that. Okay, but for passing exam you just have the formula, okay, then with the only formula you can do. Okay, but for real life you have to also understand when to use the Bayes' theorem as well. Okay, so today's question: when to use Bayes' theorem? When to use Bayes' theorem? Bayes' theorem. Okay, and also at the end of this you will also learn to form questions by yourself. Okay, so if you want to practice questions and you have watched this video, then you can form questions by yourself as well to practice. Okay, so first of all, let's start with a hypothetical question. So there is a rare disease. Okay, so let's say we denote D for that rare disease. Okay, so there is a rare disease and you are skeptical that you might have that rare disease. Okay, and the probability of you having that disease initially is 0.5%. Okay, let's make up that figure. So the probability of you having that disease initially is 0.5%. How do we come up with this? Let's say in the population 0.5% of the people have the disease. Okay, so in the population 0.5% of the people have the disease, so you have the probability of getting the disease 0.5% initially. Okay, so this is known as your prior probability. And you go to the doctor and you have your test for the disease, and it turns out that the test is positive. Okay, so the test turns out to be positive. So test is positive. And let's say we denote P for positivity. Test turning out to be positive. Positivity means test turns out to be positive. Okay, so yeah, P is for positivity, and you want to figure out what is the probability of you having the disease given that you turn out to be positive. You want to figure out this question. Okay, so this is the question that you actually have to answer. Okay, so for understanding when to use Bayes' theorem, you have to first form the question. You have to actually ask the right question. Okay, so the question is, what is the probability of having the disease given that the person is positive for the disease? Okay, and now the next question might be, what are the other informations that you need to get to figure out this probability? Okay, then the information that you need to find is related to this. It has something to do with this. Okay, positivity. So it has something to do with positivity. Okay, so you wanna know more about positivity. So what do you wanna know more about positivity? It means you wanna know more about the test. Okay, the positivity of the test. It means the thing that you wanna know about the positivity of the test is you want to know, among the people who have the disease, okay, what is the probability of the test being positive? This is the question you need to answer. And the second, among the people who don't have the disease, okay, what is the probability of the test turning out to be positive? Okay, so you want to figure about. You want to answer these questions about this parameter over here. Okay, and the questions will be related to this. Okay, if you have D, it means if you have the disease, what is the probability of the test turning out to be positive? And also, if you don't have the disease, what is the probability of the test turning out to be positive. Okay, so you want to get information about this parameter over here, and you want to ask questions about this. We need to do this. Okay, so you want to know what is the probability of positivity given one has the disease and given one does not have the disease. Okay, so let's say you do the research among the people who have the disease. Okay, you do the test. Okay, and let's say 90%, 99%. Let's say there's too much accuracy of the test. Okay, 99% of the people say that they tested positive. Okay, so among the people who have the disease, 99% tested that they have that they tested positive. Okay, and then among the people who don't have the disease. Okay, so this is not that this will be 1%. No, it's not that. If it is 99, this is going to be 1%. It's not this thing. Okay, what 1% is that probability of P complement given D is 1%. This is 1%. This is not 1%. From this you do not get this figure. So among the people who have the disease, 99% is out to be positive. It means 1% people didn't turn out positive among the people who have the disease. Okay, so from this you get this. You don't get answer to this. For getting answer to this, you have to do more research. Does that make sense? And for now I'm going to wipe this because we don't need this now. Okay, so you have to do the research among the people who don't have the disease. Does that make sense? And you do the research, you do the testing, let's say 10% turn out to be positive among the people who don't have the disease. Okay, maybe if that figure looks too much, okay, not that good, then let's say 5%. Okay, so these are just made up figures. Okay, these are just made up figures. Now you can answer this question. Okay, so this is under your belt. You can answer this question easily. So how do you answer this question? So this is your posterior probability. This was your prior probability. You now change your belief and want this to be your new belief. This is your posterior probability. This is termed as posterior probability. Okay, to answer this question, we know the formula. This is probability of D intersection P divided by probability of P. And this thing will be, probability of D intersection will be probability of D, because we cannot write probability of P because we do not know what the probability, I'm sorry, wait a minute. Okay, because we cannot write probability of P here, because if you add probability of P here, then you have to multiply probability of D given B, P, which is unknown. Does that make sense? So we have to go the other way around. We have to write probability of D. So probability of D times probability of P given D. P given D, which we did the research. Does that make sense? And divide by probability of P. What will be the probability of P? So what are the events? I mean, what are the mutually exclusive events? So the mutually exclusive events here are D and D complement. People who have the disease and people who don't have the disease. Does that make sense? People who have the disease and people who don't have the disease. And we want to write probability of P. And probability of P falls here, which is among both of them. Okay? So positivity is also for people who have the disease, and positivity is also shown for people who don't have the disease. So positivity actually lies in both portions here. Does that make sense what I'm saying? Okay? But we want to write probability of P. We want to write probability of P, which is going to be what? Probability of D intersection P, because we can see from the figure, plus probability of D intersection, I'm sorry, P intersection D complement or D complement intersection P. Okay? This is your Bayes theorem. Does that make sense? This is your Bayes theorem. Okay? If you want to solve it further, probability of D is what? 0.5%. It means 0.05. Okay, 0.05. Okay? Okay. So my arithmetic is not that bad. okay, and then we multiply it by probability of P given D, which is 99%, which is 0.99, and divided by probability of D intersection P, which is going to be what here? Probability of D times probability of P given D. Probability of P given D is known, okay, and if you say, can you not write like this, probability of P times probability of D given P, again, D given P is not known, that's why you cannot write that, okay, plus probability of D complement times probability of P given D complement, okay. If you do the calculation, you get your answer. Okay, so I have to actually wipe. What happened? Okay, so we do the calculation. So this will be what? 0.00495. Okay, 495 divided by probability of D. Hey, doesn't make sense. Don't make a noise. Probability of D, and probability of D is what? 0.005 times probability of P given D. Probability of P given D is 0.99 plus probability of D complement, which is 99.5, so it's going to be 0.995 times probability of P given D complement. So P given D complement is 5%, so it is going to be 0.05. Okay, if you do the calculation, you have the answer. So it is 0.00495 divided by, this will be, let me do 0.005 times 0.99, so this will be 0.00495 is the same thing as above, okay, plus 0.995 0.995 times 0.05 0.05, which is equal to 0.04975. Okay, so this will be 0.00495 divided by, okay, so if you do the addition, what is that going to be? Let me do. Okay, plus 0.00495. So it is going to be what? 0.0547. Let's divide it up. Okay, so there are lots of calculations to do. 0.00495 divided by 0.0547. So it's going to be 0.09, okay, percentage, approximately that. Okay, so after doing the calculation, this is approximately 0.09. Okay, so this is probability, this is not percentage. Okay, so I mistakenly said percentage, it is not percentage. In percentage, if you do it, is what? 9%. Okay, it's approximately 9%. So the probability of you really having the disease now is 5%. Okay, so it has gone up from 0.5 to 5. Why? Because the test showed is positive. Does that make sense? Okay, so your perspective has changed. Your initial prior probability was 0.5. The 0.5% probability is that you have the disease. Now it is 9%. Okay, because you had the test. Okay, so this is how you use Bayes' theorem, and I hope that this video might have helped you and you have learned something new. Okay, so and now you can also form questions by yourself and answer the questions. Okay, so this is it in this video.